Okay, let's do just quickly one more problem. So 1.4 exercises. Just to make sure that we got down the completing the squares. Numbers 35. So it says, find the center and radius. B, graph. And C, find the intercepts. X and Y intercepts. And number 35 is 2x squared plus 2y squared minus 12x plus 8y minus 24 equals 0. Okay, so the steps for completing, so the steps for going from the general form to the standard form. Okay, so the examples that we had yesterday, the coefficients of the x squares and y squares were 1. So that is the first step to before completing the squares. So divide by the coefficient of x squared. Now, if it's a circle, the coefficients of x squared and y squared will be the same. If they're not the same, then that means it's not a circle. And we'll be dealing with that later in the semester. So you divide the whole equation by that. So in this case, the coefficient is 2, so divide every single term by 2. Okay, so then you get x squared and plus y squared minus 6x plus 4y minus 12 equals 0. The second step is you want to reorder x squared and x next to each other, y squared and y next to each other, okay? And the constant on the other side. Of the equal sign. So I'm going to start with x squared minus 6x. Oh, and don't forget to leave a space. Plus y squared plus 4y. We're preparing for completing the squares. Giovanni, no, we're not in groups. And then add a 12 on both sides. So
okay, thank you.
Equals 12. Okay. Now we complete the squares. Okay, so how do we complete the squares? Take take half of the coefficient of x, square it, and add it to both sides of the equation. So I take half of -6, that's -3, square -3, and that's the quantity that I add to both sides. Oh, I guess we were doing colors. So +9, +9, and I do the same thing for y. So I take half of the coefficient of y, you square it, and that's the quantity that you add to both sides. Okay, so complete the squares. And then the fourth step will be to factor. to perfect squares. At this point, you should have perfect squares. So there's 3 terms, there's 3, so those will give you perfect squares. So x squared minus 6x plus 9, that should be x minus 3 squared, right? Plus y plus 2 squared equals 12 plus 4 is 16 plus 9 is 25. So now we have the form x minus h squared plus y minus k squared equals r squared. So we can find the center. So the center is 3 and -2, right? Because you gotta make sure that you see there's a minus and a plus. So to get a +2, the k has to have a negative. And the radius must be the square root of 25 or 5. So that's part A or there. Part B is graph and then the intercept. Okay, so 3 and -2 and radius 5. 1, 2, 3, 1, 2, -2. So that's my center. And from there I go 5 units each direction. And I guess we'll do that. 1, 2, 3, 4, 5. 4, 5. 1, 2, 3, 4, 5. 4, 5. And then we draw a circle. Okay, there you go. Almost, tiny bit more. Okay, so there's your circle with radius 5. Let's do that with blue. Okay, intercept. So the x-intercepts are these 2, and the y-intercepts are these 2. So we gotta find the x and the y-intercepts. Now to find the x and the y-intercepts, it's probably better to go to this form. Now, you see these 2 are equivalent, but the other one is already in the right form to isolate. Otherwise, you have to factor or do the quadratic formula. Okay, so x-intercept, you said y equals 0. So I get x minus 3 squared plus 0 plus 2. So that's 2 squared equals 25. So that's a 4. So subtract 4 on both sides. So we get x minus 3 squared equals 21. Am I going too fast?
Yeah, a little bit, to be honest.
Yeah, just a little bit, yeah.
Okay.
Very tiny bit.
Okay, let me slow down a tiny bit. So we're just isolating the variable. So there's a variable, so it's within the square, so get rid of the square first. And by taking the square root. So we get square root on both sides, but make sure that one side has the plus or minus. So then we get x minus 3 equals plus or minus square root of 21. 21 is 3 times 7. There are no perfect squares that go into 21. So we leave it like square root of 21, but we isolate the x by adding a 3 on both sides. Yes. So x equals 3 plus or minus square root of 21. Okay, so those will be the coordinates for this point. 3 plus square root of 21. Comma 0. And the other one is 3 minus square root of 21, comma 0. Now we go on to the y-intercept. actually y-intercepts, plural. We let x be 0. So go back to this equation, the one on the top, at the top of the page. And then set 0 for x. So I get a 0 minus 3 is negative 3 square plus y plus 2 square equals 25. Negative 3 squared is a 9. So subtract 9 on both sides to get y plus 2 squared equals, what is that, 16? 6, 9, 15. Oh, and this is a perfect square. So isolate the y, take square root. So that would be plus or minus square root of 16, which is plus or minus 4. So we have two equations, y plus 2. Let me move all the way here. So we have y plus 2 equals 4, or y plus 2 equals negative 4. So we get two simple linear equations. Isolate the variable again. So y equals 2. And the other one, subtract the 2 on both sides.
I'm
So y
sorry.
equals negative 6.
I'm sorry,
Yes.
Professor. The 2, what happened to the 2? Y plus 2? Y plus 2 equals plus minus square root of 16.
Yeah, so we're here, you're here, right? Y plus
Yes.
2 equals plus or minus square root of 16. And the square root of 16 is plus or minus 4.
Oh, okay. Thank you.
Yes. And then from there, I say, well, let's separate it into two equations because now we can simplify further. Now, before, you see, we left it as 3 plus or minus square root of 21 because there was nothing that we could do. But here we could do 4 minus 2 and negative 4 minus 2. So then the y-intercepts are these points, 0, 2, and 0, negative 6. 1, 2, 3, 4, 5, 6. So it worked out. Okay, any questions?
But this is just one problem. I'm just wondering how much time do we have for the exam? Because I noticed this took like, a little over 10 minutes to do one.
Yeah. Is the exam you have, well, when I'm doing, I'm also explaining, so it's, eventually you could do a little faster than 10 minutes, I think. The exam is a whole class time. But, some questions will be longer, like this one. And some questions may be a little shorter. No, I'm not gonna ask you 10 of this. This will be just one.
Okay.
Okay.
Also so when you did the x-intercept and you use x minus 3 squared plus 2 squared equals 25, like what made you choose those specific numbers and stuff?
The only one that I had choices was on y equals 0. So you go back to this equation at the top, and then y becomes 0. So 0 plus 2 just gives you a 2.
Oh, okay.
Okay. And then when you look at the same thing happened to the y-intercept. Yeah. X equals 0, right? So then this becomes 0. So 0 minus 3 is negative 3. And then the rest I just copied.
Okay, that makes sense. And
Okay.
Can you scroll down a little bit real quick? Or a little bit more, please.
That's it. Oh, yeah, this is it.
So you see where it says y plus 2 equals plus or minus 4?
Yes.
We don't subtract the 2 from the left side and put it and subtract it on the right side right there? Like how
Yes,
come?
we do.
Oh, okay.
But do you see, because if you have y plus 2 equals plus or minus 4, really we have two equations here, one with the plus 4 and one with the minus 4. And that's what I did here on the left side. Y plus 2 equals 4, y plus 2 equals negative 4. So I separated into two equations.
So it wouldn't have to be y equals negative 2 plus or minus 4?
Okay, yes, you can do that too. Okay, so let's see. Or you can say y plus 2 equals plus or minus 4. So you subtract that 2 on both sides. Yes, you can do that. Y equals negative 2 plus or minus 4. Sure. And then you separated that into two cases, right? So y equals negative 2 plus 4, or y equals negative 2 minus 4.
Okay, cool. Yeah, I just wanted to
Yes.
confirm you could do that. Thank you.
Oh, yeah, yeah. This is, yeah, no, this is very nice because it's more compact. So then you get a 2 and a negative 6. Yes, very nice. Okay, so let me know when you're done so we can start with chapter 2.
Excuse me, Professor,
Yes, yes.
do you think you can do one more of these problems?
One more.
Yes.
One more just like this, or one more and with a little twist?
With a little twist.
With a twist.
With the twist. Okay, so
Little twist, please.
well, let's see. Is which one you want to see again? The part of completing the squares or the graphing part, or the x and the y intercept?
The x-intercept, x and
The
y.
x and the y intercept.
Yes, ma'am.
Okay. Okay, so let's look at, so this one, negative. So let's see. 7. Yeah, I think that might work. 44. Okay, so it says find the standard form of the equation of the circle with center at negative 5,6 and area 49 pi. Okay, and then we're going to add here and then say find the x and y intercepts. Okay. Okay, so the standard form of the equation of a circle, x minus h squared plus y minus k squared equals r squared. Now here we have h and k. So we know h and k. So the only thing we don't know is r, right? But we're given the area. So if I look at the area, the formula for the area of a circle, what is the area of a circle? Pi r squared, right? So then the area is 49 pi. So you write 49 pi for A. So I get 49 pi equals pi r squared. And I want to solve for r squared. And then for r. So divide by pi on both sides. So notice that conveniently enough, pi cancels. So 49 equals r squared. So what is r?
R7.
7,
Mm,
square root
correct.
of 49. So now we have everything. So the standard form of the equation of the circle will be x minus negative 5 squared.
I have a question.
Yes.
How do you know that the area equals to the pi radius? How did you get there?
Oh, that's sort of a formula that I'm not going to ask you to prove it because then we will be able to prove it after we do calculus. So for now, you have to know the area of a circle.
Okay.
Okay. So y minus, okay, so in the exam, if there is a formula that you don't know, you can ask me and I'll see if I can give you the formula. Sometimes, you know, it depends on the problem. Like if when we're doing calculus, if I ask you to prove that the area of a circle is pi r squared, then I cannot give you the answer, right? So, but you can ask me and I'll see if I can give it to you. K is 6, y minus 6 squared equals, and now r is 7. Okay, 7 squared. So x plus 5 squared plus y minus 6 squared equals 49. Now, as we go on also, you'll start, you know, we might use the area of the circle again. So then you'll start remembering that the area of the circle is pi r squared. Okay, so here is the standard form of the circle. Now let's find the x-intercepts. Oh, let's graph it, I suppose. Graph the circle, centered as -5, 6. -5, 6. Oh, I need the left side also. Okay, so we need to move it. -5, 6. So let's see if this is long enough. Um, 2, 3, 4, 5. 4, 5, 6. And then we have to go more. We have to go 7 above 6. Okay. Okay, so then we have -5. 6 is the center. But then from there, I have to go 7 each way. So 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, I need to move it one more place. Okay. So I think it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. So those are the points. So we draw your circle. Now I'm lucky that that it fixes itself. Okay, so there's your circle. The radius 7. X and Y axis. So now we're looking at the x-intercepts. We said y equals 0. So we go back there and we said y equals 0. So x plus 5 squared plus 0 minus 6 squared equals 49, right? And 0 minus 6 is -6 squared is 36. So x plus 5 squared plus 36 equals 49. And then we keep isolating. Subtract 36. So that gives me 13. 49, yeah. Take square roots to get rid of the square. So x plus 5 equals plus or minus root of 13. And subtract the 5, so -5 plus or minus root of 13. So that would be -5 plus root of 13, comma 0. and negative 5 minus square root of 13 comma 0. So negative 5 minus square root of 13 is less than negative 5 plus square root of 13. Okay. Now, so this, you see these two numbers are negative 5 plus or minus square root of 13. Now, this is just on the side. Since negative 5 is right here, right? Then that means that plus or minus square root of 13. So then that means that this is square root of 13. And that is square root of 13. So then you get negative 5 plus or minus square root of 13. Okay, that was on the side. Y-intercept. So now we're looking at those numbers. Now notice that those numbers are, they are above about 6, right? 6, yeah, 6 is the middle point. So 6 plus this amount and 6 minus that amount. So we expect something like 6 plus or minus something. Okay, so now y-intercept x equals 0. 0 plus 5 squared plus y minus 6 squared equals 49. Okay, so we are following so far?
I have a question. So
Yes.
are you square rooting the x plus 5 squared? And is that how you got rid of the square?
Yes.
Okay,
So
Just
there
'cause
is
it's not
there
there,
is
so-
a, yes,
there we go. Okay.
yes. Okay, any other questions? Okay, so let's continue. 0 plus 5 is 5. So then I get 25 here plus y minus 6 squared equals 49. Keep on isolating the variable. Subtract 25 from both sides. So we get y minus 6 squared equals, what
24.
is that?
24.
24. Okay, so what's the next step?
To root. Yeah.
Square root. So I get y minus 6 equals plus
of
or
10.
minus. Can I simplify the square root of 24? So you're looking for a number that is a perfect square that goes into 24. So a perfect square times something equals 24.
Oh, no.
Yeah, 8 is not a perfect square. Keep on going, keep on looking.
2 square 6.
6 times 4 is 24. 4 times 6. And 4 is a perfect square. So yes, that will work. So that will be plus or minus. 4 is a perfect square, so you can take the square root. What is the square root of 4?
2.
2. And then 6 is not a perfect square, so it stays as the square root of 6. And then we add a 6 on both sides. So y equals, you see what we want, what we expected, 6 plus or minus 2 square root of 6. So that would be 0, 6 plus 2 square root of 6, 0, 6 minus 2 square root of 6. So then this amount must be 2 square root of 6. So it says 6 plus or minus 2 square root of 6. Okay. So hopefully we're feeling better about this now.
Yes.
Okay, very good.
Wait, I had one question.
Yeah.
For the x-intercept part, how did you, so I understand how you got x equals -5 plus radical 13,
Mhm.
but on the graph, did you just go, like, how did you know exactly where that was? Like the radical 13 and everything.
Well, remember, I already had the graph. Right?
Yeah.
So I already had the graph, so then I was looking for the x-intercepts. So what I got have to be the corners for those points. Right? And the corners are -5 plus square root of 13, -5 minus square root of 13. So let's do it on a real line, okay? So if you were to plot -5 minus square root of 13 versus -5 plus square root of 13,
Oh, okay, yeah,
you see it now?
yeah, I understand. Okay, that makes
Yeah. So then those are the, whatever they are. So if this is that point and that's the point, so this must be square root of 13.
okay, cool.
Yeah.
Thank you.
You're welcome. Any other questions? Okay.
No, Professor.
Okay, very good. So chapter 2. Chapter 2, we start with the concept of functions. Functions and graphs. Okay, so 2.1, we go down to basics. What is a function? Okay, so so for us, we're going to first define a relation. A relation is really a pairing between a correspondent between elements of two sets. Definition. A relation is a correspondence between elements, so whatever, of two sets, so the parts of the sets. Okay. Those two sets. Now your book is using uppercase X for one set, and usually the X is called the domain. And the set uppercase Y or the range. Okay, so a set is just a collection of elements. So for us, it's going to be real numbers. So you can illustrate by using Venn diagrams, especially if the set, if this sets X and Y are finite. So that means there are only so many elements. So then what you do is you draw two circles or ovals, and that will represent the sets X and Y. And maybe in the set X, we have the letter A, letter B. In set Y, we have the numbers 1, 2, 3. So any correspondence. So maybe I want to correspond A with 1, maybe B with 2, and maybe B with 1 also. Okay, so that is a relation. Now you can also denote the relation as a set of ordered pairs.
What does that say on the left? Venn diagrams?
Venn.
Is that
It's,
short or something?
It's a last name of a mathematician.
Okay, thank you.
Yes. So we can also illustrate a function or denote a function as a set of ordered pairs. So it's a set, so then it starts with a French bracket, and it's an ordered pair. The elements are ordered pairs, so parentheses and a comma in between. So A is related to 1, right? So A is related to 1 in this example. So then that corresponds to the ordered pair A, 1. Comma. Then there's another relation B with 1. So that corresponds to the ordered pair B, 1. And the last relation is B and 3, so B, 3. Okay, so we have a Venn diagram and we have sets of ordered pairs. You can also do a, you can also illustrate it as a graph. in a coordinate system. Okay, and it is exactly the same thing that we the way we interpret each one, a comma 1, b comma 1, b comma 3, those are represented as points. So that's the x, and there's no it's not a coincidence that we have the x-axis and the first set is the set uppercase x. Okay, they are related. So if this is a and this is b, then a comma 1 says that point, b comma 1 will be that, and b comma 1, 2, 3 will be that. So then in a coordinate system, that relation is represented by those 3 dots. Okay. Okay. Now, this set of ordered pairs. So that's sort of, again, it's not a coincidence that we have ordered pairs and therefore there's a relation with the rectangular coordinate system. And in fact, any equation in 2 variables, which is usually what we start with if we want a graph, right? In a in a plane, in a rectangular coordinate system or Cartesian coordinate system. So any equation, note, any equation in 2 variables represents a relation. Okay, so for example, so now I guess the advantage or disadvantage is that you have an expression, you have an equation, and then you can generate the points. So example, y equals x plus 2. That's an equation in 2 variables. And that represents a relation because when you graph this, do we know what is the graph of an equation of the form y equals x plus 2?
Isn't it a straight?
Parabola?
Not quite a parabola. This is a parabola will be if it has an x squared. Okay, remember that. Now there is no x squared, so it's not a parabola. Now this is called linear. Okay, and it's not a coincidence that starts with the word line. So the graph is a line. This is a linear relation. Now, when you graph a line, so we'll be going over all this. So it's okay if you don't recognize a line versus a parabola versus a cubical, because this is what we're gonna do by the end of the chapter, you know that, okay? So the graph is a line, and to graph a line, you just need 2 points, right? So usually you take the x and the y intercepts. So x-intercept, you let y be 0. So then I go to my equation. You put 0 for y, 0 equals x plus 2. You solve for x. So then I get x equals -2. And then you go and find the y-intercept. You said x equals 0. So then I get y equals x plus 2 becomes y equals 0 plus 2. So y equals 2. So yeah, 0, 2. And then you graph that. And then you get x and y, -2, 0. That's 1 point. And 0, 2. That's another point. So there's my line. And then extend it on the other side. So there's your graph. So this is a is a relation. Now, the domain. So remember, the domain are the values for X. Okay. So the domain of a relation consists of all values, namely real numbers, for X, for which a Y value can be found. Okay, so in the equation Y equals X plus 2, it doesn't matter what number you plug in for X, the Y value is plus 2, right? So you can always do a plus 2. So then the domain here, example, in the relation Y equals X plus 2, the domain is all reals, negative infinity to infinity, or uppercase R with a double bar. Any questions so far? So
Uh,
that's, go ahead.
Can you just give us a sec to copy that down real quick?
Yes, of course.
Could you scroll down a tiny bit, please?
Scroll down, that means you want to see below, right?
Thank you.
What is that? Where it says domain equals negative infinity to positive infinity equals, what is that R thing right there?
Is an uppercase R, and that stands for the set of all reals,
Okay.
all real numbers.
So the set of all real numbers would be negative infinity to positive infinity, basically.
Yes,
Okay.
yes.
Real numbers,
That's
those consist of decimals, right?
decimals, fractions, irrationals like pi, e, square root of 2, all the numbers that you can think of.
Oh, okay. All right.
So
The
that,
only thing, yeah, go ahead.
that R thing is the same thing as putting negative infinity to positive infinity, right?
Yes.
Okay, so you could
So
put either
these
or.
two are the same, huh?
We could put like either or if we were to.
Yes.
find it. Okay, sounds good.
What is
Yeah.
the R called?
Say it again.
Does the R have a name? Like, what's the technical name for it?
Set of real numbers.
Oh, okay. All right. Thank you.
Yeah, you know, mathematicians are always abbreviating. So like you have the natural numbers and you have that. So not the natural numbers. Whole numbers. I think it's a W. Integers. Usually they put like the double bar. And then we have rationals. Now, because rationals is R is already taken for reals, rationals is usually Q for whatever reason. And irrationals, wait, what is irrationals? Okay, I have to check. I think irrationals is W. Okay, I forgot. So I forgot what's the notation for the whole and the irrationals called the reals. Okay. Any other questions? The range. So the domain are the values for X, the range is are the values for Y. Consists of all values for Y that have been calculated from a particular value for X. Right, so in the domain, you look at all the values for X for which you can find a Y value. So that Y value that is being found goes to the range, okay? So it's not just any Y value on the Y axis, it has to be hit by something in the domain. Okay, so that is about relations. Now, some relations are said to be functions. So now we define which relations are functions. A relation, this is a definition. Is said to be a function from X into Y if each element in X that is in the domain if each element in X corresponds to exactly one element in the range. Which is Y. So if each element in the domain that corresponds exactly one element in the range. Okay, so for example, so 2.1 exercises. Are the following functions, page 60. So that will be problems 31 through 42. Determine whether the equation defines Y as a function of X. Whether the equation defines a function. Okay, so for example, number 32. Y equals X cubed. Okay. So now in order to answer this question, since a function, the definition of the function, let's highlight the important part. Each element in the domain corresponds to exactly one element in the range. The key is exactly one and each, okay? So then first we have to know what the domain is. So let's look at the domain. So for y equals x cubed, so when I pick a number for x, and then I substitute in, say, if I say, okay, if I were to make a table. So I want to know what values can I pick for x, right? So for example, if I pick a 2, then y will be 2 cubed. So it sounds similar to what we did before. We're looking at the cube of a number, right? So whatever number you pick, so y is that number to the third power. So is that number times itself. So then the question is, can you think of any number for which you cannot multiply times itself? Any number you can multiply by itself, right? So there's no restrictions. You can always multiply. So multiplication doesn't have a restriction. So then the domain is obvious. Or negative to infinity to infinity. Okay, so now the next questions. So I take a real number, any real number. I plug it in. So I get, like, for example, I pick 2. I plug it in, I get 2 to the third. And now my answer, what is 2 to the third? What is 2 times 2 times 2?
8.
8. Okay. Now, the key was they have to have exactly one answer. Do I have exactly one answer? Or is there another number so that when you multiply by itself, you get 8?
Yes.
Which number times itself 3 times, you get 8?
2.
2 is the one we picked. Is there another number?
No.
No, that'd be it.
No, there's no other number.
There's no other number.
Yeah.
Actually, I was going the other way around. So 2 to the third is always 8. So 2 to the third is not going to be 8 or something else. Right?
No. So
Correct.
function.
Exactly one answer. So it is a function. Yes. Okay, so there's nothing special about 2. You take any number times itself, you're gonna get only one answer. So it's not like 5 times 5 is 25 or 5, right? Or 25 or 1. There is no choice. There's only one answer. So this is a function.
If it's not a function, what's it considered?
So let's look at the case. Actually, when it's not a function, sometimes it's obvious. Sometimes it's not. Let's look at 35. X squared equals 8 minus y squared. Okay. So in order to find the domain and to see if it's exactly one answer for it, you want to solve for y. Okay, so let's solve for y. But because y is squared, then we have to solve for y squared first. Isolate y squared. So what do we do?
X squared minus 8.
Okay, so we're taking 8 to the other side. So x squared minus 8 equals negative y squared. What's the next step?
Divide by -1.
Divide or multiply by -1. -1 is special in that case. So y squared equals negative x squared
Plus 8.
Yeah, x squared over -1 minus 8 over -1. So yes, y squared equals negative x squared plus 8. Okay, next step.
Square rooted.
Square rooted. And so I get y equals, but remember when you take the square root, the one side has to be the plus or minus. So y equals plus or minus the square root of negative x squared plus 8.
Excuse me, Professor Hito.
Yes.
How did we come up with the number 1?
This -1?
Yes, ma'am.
Yes, because we're looking at, we had negative y squared, right?
Yes, ma'am.
So negative y squared, let's put this in a different color. So negative y squared, you can think of this as -1 times y squared. So then the coefficient of y squared is -1. So if I want to isolate the y squared, then you divide by -1.
Oh, okay.
Does that clarify it?
Yes, ma'am, it does. Thank you.
Very good. Okay, very good. Yeah, those little things you want to clarify, because if you let it be there, it becomes like a huge hole. And it stops you from doing other things. Okay. So here's a big question. Is this a function?
No,
No.
No. Because,
it has
oops,
2 answers.
2 answers. You get plus or minus, right? So then not a function. And in fact, let's make the answer stronger. So not a function. Because of the plus or minus, but is a, so the only time the plus or minus will be the same is when the inside is 0. So you have to look for a case because x goes to square root of -x squared plus 8 and negative x squared plus 8. Especially when, like, for example, let's find at least one value, that is, say if x equals 0, right? Then 0 goes to square root of 8 and negative square root of 8. 2 values. Not a function. Okay. So now we got the plus or minus because we took the square root, right? And we took a square root because of this x squared, y squared. So if you have a y squared, that might be a little hint that that cannot be a function. Okay, let's look at another case. By the way, this is like a little preview of the absolute value. So example, what's the absolute value of 2?
2.
What is the absolute value of -2?
2.
2. Okay, so now keep that in mind, right? So the absolute value of a number, well, the answer is always positive, and if the number is negative, the answer still has to be positive. Now let's look at 41. Same question. Is it a function? Absolute value of y equals 2x plus 3. Is this a function?
Yes.
Because
You think it's yes? Okay. So
regardless
let's see if
come out positive, right?
absolute value of y equals 2x plus 3, right? The absolute value has to be positive. Okay, so let's see if your hunch is correct. So let's take a, let's explore, okay? So give me a value for x.
1.
6.
1, okay. And then we want to find y, right? So absolute value of y equals 2 times 1 plus 3. Absolute value of y equals 2 plus 3 is 5. So the absolute value of y equals 5. What is y?
5.
-5 and +5.
It could be -5 or 5. So it's not a function.
So it's not a function. Very good. Okay. So so it's okay. You can listen to your hunch, but verify that if you are correct or not. Now, as you do more math, your intuition, you're going to be developing your mathematical intuition. So your hunches are going to start becoming correct, more and more correct. Okay. So do follow your whatever lead you get, whatever intuitive things that you get. Okay. Let's see. So hopefully there's another thing that we have to do. Or is it in there? Oh no, that's in the next section. Okay. So we have an idea of what is a function and what is not a function, or how to approach it. So now the next thing is, well, any equation in X and Y gives you a relation, but some of them are functions. So we want to distinguish between a function and a relation. So we have a function notation. When a relation is a function, we use the notation f parentheses x parentheses. Okay, so this is a package. They go together, they don't separate. It's a function. When the relation is a function, use the notation for y. Okay, so for example, what was a function? This was not a function. Y equals x cubed was a function. Y equals x cubed is a function. Therefore, we eliminate the y and instead we put the f of x. So then this becomes f of x equals x cubed. So that is a function notation. Okay. So when you're looking at f of x, you read that as f of x. As a function, this is not a multiplication. Right? In general, if you have two letters next to each other like AB, they need denotes multiplication, or AX. So AX, and even if we have that, this may mean multiplication. But you can also have this as a function, then it's not a multiplication. Okay, so sometimes if you're confused, you can just ask me, is that we're thinking of AX as a function or as a multiplication? But it usually is in the context, you can determine which we're talking about. Okay, so some advantages, one advantage of the function notation is that if we look at, let's compare, if we look at y equals x cubed, right? So when we're making a table, we say, well, let x be 2. So then that means that y equals 2 cubed. So that means y equals 8. When I'm looking at function notation, so this versus f of x equals x cubed. So I don't have to state on the side that I'm letting x to be 2. I just plug it in. And then this becomes f of 2 equals 2 cubed. So then that means f of 2 equals 8, right? So the order pair 2, 8 becomes f of 2 equals 8. Okay, so so it's a little shorter and it does have other advantages. So let's look at problem 47. I guess we should write the question first. So this is 43 through 50. Problems 43 through 50. Find the following. A, f of 0. B, f of 1. C, f of negative 1. D, f of the opposite of x. E, the opposite of f of x. F of x plus 1. G, f of 2x. And H, f of x plus h. Okay, so whatever goes in between the parentheses in the function notation, that plays the role of the x. Okay, so let's look at 47.
Is it like, that's exactly how it comes out?
Yes,
Let's get a yoga machine.
Suze, do you have a question?
No, sorry.
Okay. 47, f of x equals the absolute value of x plus 4. Okay. Oh, by the way, is it correct that this is a function?
Not a function, right?
Let's see. So
Yeah, I think it is,
It is.
it is. Why is it a function?
because the absolute value is the f of x side.
Yes, the absolute value of x gives you just one answer, right? It's always positive. And that answer plus 4 gives you one answer. So what's the difference between this absolute value and the other one that we saw? So in fact, before we compare, I'm going to write this as y equals absolute value of x plus 4. So
Yeah.
we're looking at this, and in relation, because this absolute value was not a function, right?
It's because it was on the
So-
y.
That's right. If the absolute value is in the y, it's not a function, but if the absolute value is in the x, then it's a function. Very good. Okay, so it is a function. Okay, what is f of 0? Plug in 0 for x, so I get absolute value 0 plus 4, which is
4.
4. What is f of 1?
1.
Absolute value of 1 plus 4, and that gives me
5.
1 plus 4. That's right, 5. What is f of negative 1?
So it's still gonna be 5.
It's still going to be 5 because the absolute value of negative 1 is also 1, so it's also 5. D, what is f of the opposite of x?
X plus 4.
So it's the absolute value, let's do one step at a time, absolute value of the opposite of x plus 4, right? Now, I don't know if the opposite of x is positive or negative. I could say that the absolute value of the opposite of x is the same as the absolute value of x plus 4, but then I'm stuck here because I don't know if x is positive or negative, because if x is negative, then
It's not
if
a
x,
function.
right, it's not going to be x plus 4 if x is negative. So it stays there, stays like absolute value of x plus 4. Okay, E, the opposite of f of x. So here we just put the opposite and plug in f of x, absolute value of x plus 4. And I guess we could distribute the negative, so negative absolute value of x minus 4. F of x plus 1. What is f of x plus 1? One step
X
at a time for
plus
the
absolute value X plus 1 plus 4.
very good. Whatever is within parentheses, that plays the role of the X. So that replaces the X. Now, of course, this X and that X are not going to be the same, but those are just variables. Dummy variables, sometimes they're called. Okay, G. What is f of 2x?
Absolute value 2x plus 4.
Very good. H. F of x plus h.
Absolute value x plus h plus 4.
Very good. Okay. Any questions?
No.
Wait, can you go over the letter E real quick one more time, please?
Yes. So E, so we're looking at, you see, if you have a negative in front, that doesn't mean that the expression is negative. So I usually just say the opposite. So this one means the opposite of f of x. So then the opposite, and then you substitute what f of x is. F of x is the absolute value of x plus 4.
Oh, okay, that makes sense. Thank you.
Oops. Yeah, you're welcome. And then that takes you to that. Any other questions? Okay, so moving along. So the function notation sometimes creates problems. So you want to make sure that you practice this. Then the next topic is find the domain. 51 through 70. Find the domain. Oh, find domains. So what is the domain again? If you need a quick refresh, domains consist of all values for x for which we can calculate a y. Okay. We're looking at okay, so we did x cubed and x cubed, you can always calculate a y. Let's look at 56. H of x equals 2x over x squared minus 4. Okay, so what you do in order to find the domain, you look at the operations involved. Okay, so if you pick a value for x, what are the operations involved? So once you plug in for x, you're going to be multiplying, right? So operations involved here are multiplication. And for multiplication, there is no restriction. You can take any two numbers and you can multiply. So there is no restriction. Okay, but then there is an x in the denominator also. When you're squaring, which is multiplication, no restriction, there is the subtraction. Subtraction, there is no restriction also. You can subtract any two numbers. So subtraction doesn't give me a restriction. The last operation is division. Okay. Division has a restriction because there is a number by which you cannot divide by. What is that number?
0.
0. Okay. Cannot divide by 0. So that's what you're looking for. You're looking for restrictions. So if you have a function that has only multiplication, subtraction, no restrictions, so the domain is all reals. But if you have a division, then you have a restriction. Cannot divide by 0. So then that means that you look at the denominator, x squared minus 4 cannot be 0. Okay. So then what you do is you find when is 0 and then you take away those points. So x squared minus 4 is 0 when, I guess we can isolate the x, when x squared equals 4. So then that means that x must be
2.
2.
plus or minus 2. Don't forget the plus or minus. Okay, so these are the ones that make the denominator. So x equals plus or minus 2 makes the denominator equal to 0. So then that means that those numbers cannot be in the domain. So then the domain equals the set of x's so that x is not equal to plus or minus 2. Any questions?
Yes, can you repeat that?
Yeah, please.
Okay, let me take it twist it around. Okay, find f of 2. So then I go back to my function, plug in 2 for x. I get 2 times 2 over 2 square minus 4. Keep on simplifying. 2 times 2 is 4 over 2 squared is 4, 4 minus 4. Keep on going, so I get 4 divided by
0.
0. And what is 4 divided by 0?
Cannot be divided. 4.
0 cannot divide by 0, and that's called undefined.
Okay.
So what happened? We found the numbers that make the denominator 0. So how did we find the numbers for which the denominator is 0? We actually took the denominator, x squared minus 4, you set it to 0. And then we solve that equation.
What is the symbol after 2 in the answer?
It's a French, it was supposed to be a French bracket to close the set. That?
Yes, thank you.
Yes. So this is the notation for sets. For sets. Okay. My handwriting is getting closer and closer to a doctor's. Scribbles. Okay.
Wait, can you read the
Here,
yeah, the
denominator.
yeah.
So let me spell it out correctly. Denominator. Next, then the denominator 0. So, and for division, we cannot divide by 0. So we actually don't want those values.
How do you read where it says D equals French bracket X?
So you read this as set D with elements X, and then the vertical bar stands for so that, or with a condition, so that X is not equal to plus 2 plus minus 2, or nor, I guess, nor negative 2. So this stands for so that, or some people say with the condition that x is not equal. Okay, let me give you a problem. I don't think I took roll yet. Let me give you a problem for you to work on and find the domain. And that was number 56. Let's do 58. G of x. It's gonna be similar to the one we did. And then tomorrow we'll do other types of functions. X plus 4, x cubed minus 4x. Yeah. Okay. So what is the domain? Did anybody get it? So like before, the numerator has an addition that doesn't give you any problems. The denominator has a subtraction, multiplication, and power, no problems with that. So the only problem is the division. Cannot divide by 0. So we look at the denominator. You set it to 0 to take out those points. So we get x cubed minus 4x equals 0. And then how do we solve this equation? This is a nonlinear equation. Maybe this is where we got stuck. So in a nonlinear equation, one side must be 0, which in this case is, otherwise you just subtract whatever is there. And 2, you factor. Okay, so first thing to do is always the greatest common factor. So x cubed and 4x have x in common, so you factor that out. Okay, so x times, to get x cubed, I need x squared. So x times x squared will give me x cubed. And x times negative 4 will give me the negative 4x. So then you set each factor to 0.
Can you repeat that?
The greatest common factor?
Yeah.
Yes. So what you put in here, so you can see that x is common, right?
Yes.
The x cubed and the 4x have x in common. So
But how did you
the-
get to it?
How do I get the other parts?
How did you get the x?
As a common
Three.
factor?
Yeah.
Okay. So I look at the x cubed. So we have a factor means that it has to be, it is related to multiplication. Okay. So like, for example, I cannot say 4x is a factor because there's a subtraction there. So, but among these two terms, the x cubed and the 4x, because x cubed is x times x, right? And the 4x is 4 times x. So then you see among these two parts, what do they have in common? The x, right?
Yeah.
Right, so that's one way to do it. So x is common. Now, if you spell it out like that, actually you can see it very clearly. Then you take that what's common out, right? And whatever you take out, so I took out the x and that x, so whatever I'm left, that goes inside. So I get x times x goes inside, that's x squared, and then minus 4. Okay. Now you can take this further and say, well, x squared minus 4, it can be factored. that's a spatial case, is a x squared minus 4. You have to think of this as x squared minus 2 squared, and that's called the difference of the squares. Do we remember how to factor difference of the squares?
It's plus or minus, right?
X plus 2, x minus 2. Yes. And you can check this by FOILing. Okay, so x1 minus 4 becomes x plus 2, x minus 2. Now set each, then is step 3, set each factor to 0. So we get this. So the factors are the ones that are separated by multiplication. So x is 0, x plus 2, 0, x minus 2, 0. So here we have one answer, x equals 0. For the second equation, we isolate the x. So then we get x equals -2. And what do I get for the third equation?
Positive 2.
Positive 2. We add a 2 on both sides, so we get x equals 2. Okay, so 0, -2, and 2 makes what? The denominator 0. So then that means that 0, 2, and -2 cannot be in the domain. So what is the domain?
Sorry, why was the x equals 0?
Okay. Let's check. And let's see what happens. X equals 0. Okay. So if I check over here, usually you check on the top, but let me check over here so that you can see why. So then I put a 0 times 0 plus 2 times 0 minus 2, right? So I get a 0 times 2 times -2. What is that equal to? 0 times 2 times -2?
0.
0, right? 0 times 2 times -2 is 0 times -2, so it's 0. So, and that only works if you have a multiplication. So if you have a multiplication like here and there, if one factor is 0, like in this, then it doesn't matter what the other ones are, because whatever these are, oops, whatever these are times a 0 is going to be 0. Now, we go back to this expression and it says, well, I have this product, x times x plus 2 times x minus 2. So to get the product equals 0, one of those three things have to be 0, at least one. So one of them is x. So there you go. Does that answer your question?
Yes, thank you.
Okay, very good. Any other questions?
When we write it down with the domain format,
yes.
is it
Okay, let's write it down. So D equals the set of all x's so that what?
0,
X
you have to
is
put like
not equal to
to
0,
negative
right?
1, 2.
Or is not equal to -2 or
2.
2. So there you can do plus or minus 2 also. So that would be your domain.
Do we have to write the letter o, the word or can we put separated by commas? Or does it-
Yeah, you can separate by comma.
Okay.
So after the x is not equal to 0, we could just put comma plus or minus 2, and that'd be correct.
Okay, yes. So yeah, there we can, if we want to abbreviate it, x not equal to 0, comma plus or minus 2. That would be the shortest. Or you can also do x so that x is not equal to 0, comma, x not equal to plus or minus 2. Yeah, you can have any of those versions. Okay, so now this is office hours. You can stay back and then we can do more problems. I can answer your questions. Or if you have to go, I'll see you tomorrow. I think I'm gonna change my office hours. I'm gonna add office hours before class and I'm gonna shorten the one after class, okay? It'll be posted on
Why?
the homepage.
Why?
Oh, because my class before this one, it seems that they need a little bit of office hours after that class.
Professor,
So,
can you go back to number 44? It's find the standard form of the equation of circle C and area, whatever. I didn't get a chance to finish drawing the graph. Yes, thank you.
Yes.
And Professor, I wasn't able to attend the first day of class, which I believe was yesterday.
It was Monday.
It was Monday,
Yeah.
and it's just Monday and Wednesday, right? And
No, Monday, Tuesday, Wednesday, Thursday.
oh, so I mean, yeah, so I missed both days.
So you missed
Monday and Tuesday.
Monday and Tuesday.
Are there recordings for that?
So just watch the recorded lectures and then you let me know and then I'll excuse your absence.
Okay, all right, thank you very much. I just signed up yesterday. I went to LAVC in person.
Oh,
Same thing for Melanie Esteban. We're actually also at PCC currently.
okay. So then, yeah, so do watch the videos. You know where to find the videos?
I'm pretty sure I'll be able to figure it out.
Yeah, just go into Zoom and then click on cloud recordings.
Okay,
Okay, and then watch the 2 videos. Once you guys are done watching, then send me an email.
okay, if we have any questions, I'll log in before class tomorrow.
Okay, and before class, it will be a different link.
Okay,
Okay, but it will be on the homepage for office hours. You'll see
Okay.
that.
all
Okay.
right. All right,
Okay.
thank you, Professor.
Okay,
Thank you, Professor Hiro. Talk to you
you're
tomorrow.
welcome. See you
Bye-bye.
tomorrow.
Thank you.
Bye.
Miss, I have a question.
Yeah.
So for the homework, the first part where it's just the vocab and like explanations, do we have to show work for that or no?
For which section are you talking about?
For 1.1, the vocab area, do we have to show work for that or no? Like
No, I don't think so. Let's see, let me verify. Oh yeah, the X coordinate, the Y coordinate. Yeah, for vocabulary, no, you don't need to.
all right, thank you very much.
Mhm.
Can you help me with one of the homework questions, actually?
Yes,
I need some of the homework questions too, so.
Should I like, do you want me to just read it to you or should I like screen share? it?
yeah, is it from the book or from the,
It's from my math lab.
okay, then you tell me.
Okay.
Oh, are we done with copying?
Oh, yeah.
Yes, thank you.
Okay, so let's scroll down. Okay, so then we have. Okay, what section is that?
1.4. It's like a radius circle question.
Okay,
So maybe I could just review my notes, but if you could go over it real quick. It says, find the center and radius of the circle, write the standard form of the equation. And then it gives me the circle if you want the coordinates.
yes.
So the coordinates are 4, 7, and then 15, 7. And then it has a dot in the middle of the circle.
Okay, 4, 7, and 15, 7. Okay, so this is, I think it's like the number 11. So it's like So
For me-
it may be 1, 4, 11. So,
Oh, yeah.
right?
Yes.
Okay, so basically you have this. And then we have,
Yeah, it looks like that.
so let's see. So this is the center and 4, 4, 7 will be this. And
Mhm.
15, 7 will be that, right? And the center is in the middle.
Yeah, that's what it shows.
Okay, so find the standard form of the circle. Okay, so 4, 7 and 15, 7, they determine a diameter,
Mhm.
right? So then this is a diameter. So then that means the center is the midpoint. So find the midpoint of 4, 7 and 15, 7. So what is the formula?
It was like x2 x1 over 2 something, x2 x1 over 2 something like that.
Yes, x2 plus x1 over 2. So it's the average, y2 plus y1 over 2. Okay, so what is that equal to for this problem?
15 plus 4 over 2 and then 7 plus 7.
Okay, so simplify and we get,
Let's see, 19 over 2 and then 7.
yes, so we have the center. So we have h and k. What is the radius?
The radius equation or
So the radius will be a length. So it will be a distance from the center. So let's say this is P. From the center to P or from the center to Q, whichever you want to do.
okay.
Okay, so now we use the distance formula. Square root of,
1 sec, let me write that down. Or equals x2 minus x1 plus y2
Square.
minus y1. Oh, yes.
don't forget square. Okay, we apply that and we get square root of
15 minus 4.
15 minus 9. Oh, I see. You want to do the diameter.
I thought, oh, CP. 50.
Yeah. You could also do the diameter,
oh.
which is QP.
Oh, so I could just use the 15 minus, what would it be, 19 over 2
Yes,
instead? Yeah, okay.
that will be for the radius.
Yeah.
But it's true that you can also do the diameter and then just divide by 2. Plus 7 minus,
7 minus 7.
right. Which is 0.
Yeah.
And then 15 minus 19 over 2, that's like 30 over 2 minus 19 over 2. But the square and the square root cancel, so it's just 30 minus 19 over 2.
Where'd you get the 30 from? Did you just multiply 15 times 2?
Yes. So we made this over 1, so times 2 times 2.
Okay. So 30 over 2 minus 19.
So what's the answer?
Let me put it. 11 over 2?
11 over 2. Okay. So now just put it into the equation x minus h squared plus y minus k squared equals r squared.
That's standard form equation, right?
Yes. Yeah. And the other one is the general.
So x minus h squared. So would it be x minus That's what I'm saying. What H and K do I use? There's like so many different ordered pairs.
There is only one H and K, and that has to do with the center.
So H and K is always going to be the center.
Always the center.
So it'd be X minus 19 over 2
Yes. Square.
Plus Y minus 7 squared
Yes.
equals 11 over 2 squared.
Yes. Let's multiply out the 11 over 2 one step further.
You said what?
Simplify 11 over 2 square.
That is like what, 5.5, something like that.
No, just leave it as a fraction.
Okay, let me see.
So it's 11 over 2 times 11 over 2.
2 and 3/4. Oh no, that's a mixed fraction.
Yeah.
So 22 over 4.
11
my God,
times
not 20.
11.
I'm tripping.
Yeah.
Tripping.
But
120.
the good
120.
thing is, yeah, the good thing is you caught your mistake. So
Yeah.
it's
121 over 4.
yes.
2 times 11.
Okay, now notice that if you use, instead of 11 over 2, if you use 5.5, right?
Mhm.
Then this is not equal to 5 squared times 1/4. Okay, so it doesn't distribute because the inside is a sum.
So it's better
you-
to just keep 11 over 2.
yeah, just leave it as a fraction.
Yeah.
So it's better to do it that way.
So after you get to that final equation, the X minus 19 over 2 squared, is that like the final answer?
Yes, that's your standard form.
Okay.
What else did they ask? That's it, right?
Yeah, it just says circle into the center of the circle is, it's probably gonna ask for like 3 different parts, but yeah, the center, radius, and standard form. So that's everything.
Yeah.
Okay, cool. Thank you.
You're welcome.
Okay. I don't know if anyone else had a question.
Okay. Yeah, if anybody has a question, just let me know.
Yeah, I have like a couple of questions from the 1.1 section that I guess I didn't understand.
Okay. You're doing the textbook?
Yeah, from the 11th edition textbook.
Okay, so which problems?
So there were problems 49, 55, and 57.
49, 55, and 57?
Yes.
Okay. All right, 49. So this is page 7. Find all points having an x-coordinate of 3 whose distance from the point -2, -1 is 13. So having an x-coordinate 3. So all points of the form 3 something, right? Whose distance from -2, -1 is 13. Okay, so basically find the y values that satisfy that condition, right? So then you just apply whatever the condition is. So we have a point, let's call point P and point Q. So then the condition is that the distance from P to Q is 13, isn't that right? Does that make sense?
Yeah, that makes sense.
Okay, so then you apply the distance formula to P and Q. So what do you get? So we can call this x1, y1, x2, y2. So we get, so the distance formula, square root of x2 minus x1 square plus y2 minus y1 square, and everything inside the square root. Okay. So let's apply. So we get x2 is -2 minus x1 is 3 squared plus y2, which is -1 minus y1 is y squared, right? So now here, if you look at carefully, there is only one variable, right? And it's an equation, there's an equal sign and two sides. So then basically what you have to do from now on is solve for y. Now we can get rid of the square root by square on both sides. And then we simplify, so you get -2 minus 3 is -5 squared plus -1 minus y squared equals 13 times 13, which is 169. And of course that's 25, so subtract 25, because this is 25. So then I get -1 minus y squared equals 144. What is the next step? We have y squared equals that. So then maybe take the square root. So -1 minus y equals plus or minus square root of 144. Are we following?
Yeah, I'm following. So the
Okay.
so you just get the square root of 144, which is 12, right?
Right. Oops, I did 12. And then you just isolate the y.
Oh, okay. I don't know why I found this so confusing, but that made it so much better. Thank you.
Yeah. Actually, yeah. So you just apply what the condition is, but let's take it all the way. So I get -y equals 1 plus or minus 12, and then you multiply by negative, so y equals -1 plus or minus 12. So y equals -1 plus 12, or y equals -1 minus 12, so y equals 11 or -13. So so then the points for P are 3y, so 311 or 3 -13. Let's verify. So it's saying the distance from P, from those P's to Q is 13. 11. Okay, so hopefully okay, so let's see if that works. X and Y. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that was one. So it's 11. So 311 is there. And 3 -13. Okay, so we have 1, 2, 3, 7, 8, 9, 10, 11, 12, 13. -13. So we're saying that these 2 points and are 13 units away from -2, -1. So the distance from there to there and from there to there is 13. I think it was 13, right? Yeah. The distance from -2 to -2 comma -1 to 311 and 3 -13 is 13. Okay. Any other questions?
No, that was actually very helpful. Thank you.
Good. Okay.
Can you help me with one more question real quick?
Yeah.
So I figured out, I solved this question, getting the standard form of the equation, but now it's asking for the general form. Can you help me get
Is it the
that?
problem we did or something else?
No, it's a different problem.
Okay.
It gave me HK and the radius, so I basically plugged in the standard form. And then now I don't know how to get the general form from that.
Okay, so find the general form.
Yes.
So that must be 1.4.
Yeah.
Okay,
And
so
again-
what is your equation?
So the standard form equation is x minus 0 squared plus y minus 0 squared equals 81. That's the standard form right there.
X minus 0 square plus y
Y
minus
minus
0
0
square equals 81.
Yeah, and then the center HK is 0, 0, and then radius equals 9.
Yeah, that's correct. Now, because of the 0, you know, x minus 0 is just x. So then that's x squared plus y squared equals 81. So
Okay.
that's your general form.
Oh, really?
Yeah, there's nothing to do.
So if there's not, so what would A, B, and C be in like a real general form? What would that be?
0.
Squared equals-
So this is the same thing as x squared plus y squared plus 0x plus 0y minus 81.
No, I'm saying like, say it was another equation, what would that X and Y? Oh, so C is the radius? Like where you said negative 81?
No, in this case it's a radius, but if this were not 0, then there will be other numbers that will combine with the 81. So you'll lose the radius. So let's look at another case.
Yeah, can you show me that? Let me submit that real fast so I can.
Yeah.
X squared. Y squared equals 81. Hold on. I stayed up all night doing 1.1.
1.4
Or the other one, the other
or
homework.
1.1?
Yes.
Oh,
X squared plus y squared equals 81. No, I put in x squared plus y squared for the general form and it said it was incorrect.
okay, let's see if I can find that problem.
Yeah.
Maybe they want you to put plus 0x plus 0y, I don't know. Let's see,
Oh, possibly, yeah.
right? It's a possibility. It's not in the wrong. Okay, so my courses.
Maybe I have to write that whole thing 0x 0y.
Okay, let me just check. Do you remember what number was it?
It says 1.4.13.
13. Number 13.